Well, in this question, we are asked to find out the total work done by all the forces which are acting on this block. And this block is displaced to a distance of 3 meters, and this block is placed on an inclined plane, and that is inclined at an angle of 30 degrees with the horizontal. So first of all, we need to find out which are the forces which are acting on this block. So first we consider weight. So this is the weight, and its value is given as 50 Newton. First we need to resolve weight into its components. So these are its components. This angle is also of 30 degrees. So this component will be W sine of 30, and this component will be equal to W cos of 30. Now we need to take into account this force and resolve it into its components. These are its components, and this component will be the same as F sine of 10, and this component will be F cos of 10. Now these are the two components of the force. Now there is another force, which is force of friction, which is acting downward or against the motion, and its value is given as 2 newtons. So now we need to figure it out that which forces are relevant in this case. So the forces which are either assist the motion or it resist the motions are the relevant forces. So first we need to take into account again the weight and find out that which component is relevant here. Now this component, that is W sine theta, is relevant here because it is resisting the motion of the block which is acting downward, and our motion is in this direction. We are pushing the block upward. So what is the work done by this force? We need to find out the work done by this force. Then we need to find out the work done by the component of the force of 30 Newton. Now these are the two components of the force, that is the force of 10 Newton and 30 Newton, which is acting at an angle of 10 degree, and only this component is relevant because it is along the motion in the direction of the displacement. So we need to find out the work done of this force as well. And similarly, we will have to find out the work done by the force of friction because it is also in line of the motion, although it is resisting the motion. So first of all, let us take this force F is equal to 30 Newton and find out the work done by this force. And now we know that only this component is relevant here. This is not relevant because there is no motion in this direction. So work done by the force F, and that will be equal to the relevant component of the force, that is F cos of 10 multiplied by the displacement. We know that displacement is 3, and when you put all the values here, F is given as 30 Newton, put F is equal to 30 Newton into cos of 10 into 3, and you will get 88.6 joules. So this is the work done by the force F. Next, we need to find out the work done by this force of friction. So let's take the notation F of R, noting the work done by the force of friction. And again, it is equal to the force of friction, that is 2 Newton, multiply displacement, and that is 3. And it will become 6 joules. Now, since the direction of this force, that is of 2 Newton, and the displacement is along this direction, and the force of friction is acting along this direction. Therefore, we need to put a sign of minus. The work done will be negative. Next, we need to find out the work done by the weight, or the relevant component of the weight. The relevant component here is this one, because there is no motion along this component. Therefore, the work done by the weight component is equal to the relevant component, that is W sine of 30 multiplied by the displacement. Now the displacement is of course 3 meters, and W is given as 50 sine of 30.5, I think so, and then multiply by 3, and the answer, when you calculate it, it will become 75 joules. Now look at the direction of this component of weight. It is again against the motion, against the displacement. Displacement is in this direction, and this component is acting in this direction. Therefore, its value is negative. So what is the total work done? So total work done will be equal to the sum of all these work dones. So the first work done is 88.6 joules, and then we need to add it in minus 6 and then minus 75, and you will get 7.65 joules. So this is the total work done by all the forces.